Good morning, everybody, and welcome to the shortest lesson that we've ever had. It occurred to me as I was looking over some things that we missed something. We missed a couple things, I'm sure, but there was one thing I know that we missed, and that is a relationship that tangent theta has with a basic line graphed on the coordinate plane. And so when we think about a line graphed on the coordinate plane, we think y equals mx plus b, where this is in slope-intercept form, so therefore that's the slope, and this is the y-intercept, okay? And so if for some reason a line was just to say y equals 3x, we should know that that means that this is the slope, it's got a slope of 3, and the y-intercept is 0, which would mean it passes through the origin. So if you think about it, it would be this really steep line coming right through the origin, because it's got a slope of 3. Okay, and so anyway, all of this to be said, this is some basic Algebra 1 review. Y equals mx plus b is the equation of a line. M is the slope. B is the y-intercept. Well, there's something that connects this to trigonometry, and that is that if you have the equation of a line, tangent theta is always equal to the slope of that line. When I say that, I mean if we're saying theta is in standard position like this, okay? And so right here, if this were to be theta, the angle theta in standard position, and it laid right here on this line, y equals 3x plus 0, well then, if I knew nothing else, I would know that tangent theta is equal to 3. And from that, I can find everything else. If I knew that tangent theta was 3, just think about some of the trig identities that we know. You know, you think about it, you go, okay, so I'm just going to start, right, say sine theta and cosine theta. Let me scoop this up a little bit. And tangent theta. Okay, so we're saying, well, we know that tangent theta is 3, so therefore cotangent theta would have to be 1/3. Okay, what else do we know? Well, we know that there's a relationship between tangent theta and secant theta. Okay, and what was that relationship? Well, you know, it always goes back to the x squared plus y squared equals r squared, but we should hopefully, by this time, hopefully we're kind of past that, and we go, well, I remember that secant squared theta is equal to 1 plus tangent squared theta. Okay, I don't have any little easy trick to remember that, but that's one of the Pythagorean identities. And so if I know tangent theta, which I do over here, then I could literally just plug that in and say, well, then I know that secant squared theta is equal to 1 plus 3 squared. So therefore, secant squared theta is equal to 1 plus 9. So secant squared theta is equal to 10. So therefore, secant theta is equal to the square root of 10. And if secant theta is equal to the square root of 10, then cosine theta would have to be equal to 1 over the square root of 10. All right? And once I've made it to that point, I could kind of keep going a little bit, and I could think about this and say, wait a minute, I know that cosine theta and sine theta always have the same denominator. So that would mean that would have to be square root of 10 on the bottom. And that tangent theta, remember, tangent theta is always equal to sine theta over cosine theta. And that was because it's y over r over x over r. And so this and this come from these, resulting in this. So let's take a quick look and go, well, tangent theta is 3 over 1. And so let's think about that. This right here is where that 1 came from, and this right here would have to be where that 3 came from, okay? And then if I know that sine theta is 3 over the square root of 10, then I know that cosecant theta would have to equal square root of 10 over 3. And I have all of them, okay? Now that was a really fast blur of a problem. So let's try it again. Okay? Let's say I am given the equation y equals negative 2x, okay? And we are talking about, we say that theta terminates in quadrant 2. Okay, now just to give you an idea, we should probably have an idea of what this looks like. Okay, y equals negative 2x would look something like this. And we're saying, here's theta. You know, theta is on the line y equals negative 2x. And it's in quadrant 2. So that's something over here, okay? And so from that, let's think about how we did this. Well, we said we know that tangent theta is equal to the slope. And if that's the case, then tangent theta is equal to negative 2. Okay? And if tangent theta is equal to negative 2, then cotangent theta is equal to negative 1/2. And why is that? Well, because those two have a reciprocal relationship. And then we say, well, we know that secant squared theta is always going to be 1 plus tangent squared theta. So then if I square this negative 2, which would give me a positive 4, then I would say secant squared theta is 1 plus 4, which of course is 5. So therefore secant theta is going to be the plus or minus square root of 5. Now last time I had kind of shown that we were in quadrant 1, so I didn't worry about the plus or minus. I should have addressed that right here, but we were in quadrant 1, everything's positive. Here we've got to pay a little bit more attention. We are in quadrant 2. And secant, remember secant deals with x, and we are looking at a quadrant where x is negative, so we want the negative. Okay, so we're dealing with secant theta is negative square root of 5. And if we know what secant theta is, then we know what cosine theta is. So I can say, well, cosine theta would have to be negative 1 over square root of 5, while secant theta is negative square root of 5. We know that tangent theta was negative 2, and cotangent theta is negative 1/2. And now we go, okay, remember, sine theta has the same denominator. It's going to be square root of 5. Quadrant 1 is going to be positive. And let's see here. What would it have to be? We know that tangent theta is 2 over 1, or negative 2 over 1, or 2 over negative 1. And this came from right here. And this goes right here. Okay? And therefore, cosecant theta is the reciprocal of that. Square root of 5 over 2. And it's that easy. Now, the more you practice this, the better you'll get at it. But I know we might be moving kind of fast. So now with this kind of here and me working through my logic, what I want you to do is I want you to try one. Okay? And we're going to start real easy. Let's just, for the sake of keeping it simple, we'll do one where everything is positive. Okay? And so how about we go, we'll use the equation y equals 2/3 x. And we're talking about where theta, it terminates in quadrant 1. Okay, what I want you to do is we're going to pause the video right here, and you're going to try to find all 6 trig ratios based off that information. So go ahead and pause the video and give it a shot. Okay, hopefully we're back and you're feeling pretty good about this, or maybe you're not, but now you've given it a try yourself, and so we can see this. So we're going to take this information, this y equals 2/3 x, and we're dealing with this in quadrant 1, so everything's positive. Now immediately you should be able to say, well, I know that tangent theta is 2/3, and why? Because tangent theta is always equal to the slope right here, okay? And if I know that, then I know that secant squared theta is equal to 1 plus tangent squared theta. So I square this value right there, and I know that secant squared theta is equal to 1 plus 4/9. Well, how many ninths is 1? That's 9/9. So secant squared theta is equal to 9/9 plus 4/9 would give me 13/9. Okay? So therefore, secant theta is equal to plus or minus square root of 13/9. We said we're in quadrant 1, so everything's positive. So square root of 13 over 3. All right. So now let's do all 6 trig functions. So you got sine theta, cosine theta, tangent theta. So we're going to start off with our tangent theta is 2/3. Cotangent theta, 3/2. secant theta is right there. Square root of 13 over 3. So therefore, cosine theta, 3 over square root of 13. Sine theta always has the same denominator as cosine theta. This 3 was right here. This 2 must go right here. And therefore, cosecant theta is square root of 13 over 2. Okay, hopefully that made some sense. What I'd like you to do is I'd like you to try one more and I'll work through it, and then we'll get you going on some things for today. Okay, so the last one we're going to try, I'll put it right here in the middle. How about this? Let's make it a little bit more interesting. We'll say that is y equals, and we'll keep it pretty simple, y equals 3x, but this time we're going to say that theta terminates in quadrant 3. So that's going to throw some things off a little bit. Okay, you got to think about that. Now y equals 3x. Real steep line going through the origin, but this time we're saying that theta goes all the way to here. It terminates in the third quadrant down here. Okay, so once again, we're going to pause the video for just a couple minutes and give you guys a shot at this, and then we'll see if our answers match up. Okay, we're back. Let's give this a shot. Excuse me. So we're going to take this information. I think by this point you should be moving pretty quickly with this. You go, okay, so tangent theta is clearly 3. And you go, wait a minute, should it be positive 3? Absolutely. In quadrant 1, we have positives and positives, which make positives. And in quadrant 3, we have negatives and negatives. And a negative divided by negative is positive. Okay, so we know that tangent theta is 3. That would mean that cotangent theta has to be 1/3. Then we can go, I know that secant squared theta has got to equal 1 plus tangent squared theta. So therefore, secant squared theta is equal to 1 plus 9. So secant squared theta is equal to 10. Secant theta is equal to plus or minus square root of 10. Which one is it? Down in quadrant 3, it's got to be negative square root of 10. Okay, let's put it all together. Sine theta, cosine theta, tangent theta. 3 for tangent theta, cotangent theta is 1/3. Secant theta is a negative square root of 10. So therefore, cosine theta is negative 1 over the square root of 10. Sine theta has got to be over the square root of 10. Also got to be negative, and it's got to be this number. Remember, this is this. This one goes here, and this one goes here. And then we just flip it to get to cosecant, negative 10, or negative square root of 10 over 3. Hopefully that's what you got. Okay, you're going to try a sheet with 4 problems on it right now, just to try to put all of these things together, x squared, y squared, r squared, trig identities, and even the stuff with tangent. You're going to give that a shot for, 20 minutes, maybe less, and then we'll work through those problems. All right, see you in a little bit.